Have you ever wondered why these multi-million-dollar robots, with all their advanced AI, can still be so clumsy? Well, a big part of the answer lies in a sense they've been missing, a real, nuanced sense of touch. Today, we're diving into a huge breakthrough called Sparsh-skin that might finally teach robots the art of dexterity. Right? We've all seen those videos online. You have these incredibly sophisticated machines that can do amazing calculations, but then they try to pick up an egg and oops. Despite all the progress we've made in AI, their hands just don't have that subtle feedback that our own sense of touch gives us. And that makes them, well, surprisingly clumsy at simple tasks. And really, it all comes down to this missing sense of touch. I mean, think about it. How do you play a guitar? Or maybe a better one, how do you plug in your phone charger when the lights are off? You're not using your eyes, you're feeling for it. It's a sense we totally take for granted, but for a robot, it's the last crucial piece of the dexterity puzzle. So, how are scientists and engineers trying to crack this problem? Well, there are basically two leading approaches right now. The first one is all about vision, sticking tiny cameras on the robot's fingers to see what it's touching. But the second, and the one we're going to focus on today, uses this really cool tech called magnetic skin.
And when you put them side by side, you can really see the difference. Vision-based sensors are pretty popular, yeah, but they're also kind of bulky and slow, and you can really only use them on the fingertips. Magnetic skin, though, it's a whole different story. It's flexible, like actual skin, so you can cover the entire hand. It's super fast, reacting about 100 times a second, and it gives you a much richer sense of all the forces involved. This stuff has the potential to be a total game changer.
But, and there's always a but, right? Here's the catch. The researchers behind this work pointed out themselves. All that amazing, rich data you get from magnetic skin is also incredibly complex. The raw signals are just noisy. They're hard to make sense of, and even harder to build a model for. So for a long time, we've had this amazing sensor technology just sitting there, held back because nobody really knew how to translate what it was saying. Until now.
And this is where the big breakthrough happens. This is Sparsh-skin. It's a completely new way to finally process and understand that incredibly complex language of touch that's coming from these magnetic sensors.
So what is it exactly? Well, first, the name. Sparsh is the Sanskrit word for touch, which is just perfect. At its core, Sparsh-skin is a pre-trained model. You can almost think of it as a universal translator for the sense of touch. It learns these general ideas of what touch feels like by looking at tons of raw, unlabeled data. So you don't need a person sitting there telling it, okay, this is soft, this is slipping, for every single interaction. So here's a quick rundown of how it works. Sparsh-skin looks at just a tiny tenth of a second slice of touch signals from all over the hand. We're talking fingertips, knuckles, the palm, everything. It crunches all of that data down and outputs one single information-packed summary. The fancy term is a latent tactile embedding, but you can just think of it as a rich, compact understanding of the touch event. And that one little summary can then be used to help the robot do pretty much any manipulation task you can imagine. Okay, but how in the world does it learn all this stuff without a human having to label thousands of hours of data? Ah, well, that is the secret sauce, and it's a huge innovation all on its own. The answer is this really powerful technique called self-supervised learning, or SSL. Basically, instead of waiting for a human to give it the answers, the model creates its own little pop quizzes from the raw data it's seeing. And this is totally revolutionary because it slashes the need for all that expensive, super time-consuming data labeling that has been a massive bottleneck in robotics for years. Sparsh-skin uses this really clever version of SSL called self-distillation. Picture this. You have a student network and a teacher network. You show the student a corrupted or incomplete signal, like a fuzzy picture of the touch data. The student's only job is to try and guess what the teacher is seeing, because the teacher gets to see a much clearer version of that same signal. Then the teacher slowly gets smarter by averaging in what the student has learned. It's this beautiful loop where the system is effectively teaching itself, getting better and better with every cycle. And this is where the research team got really creative. They figured out pretty quickly that you can't just copy-paste techniques from computer vision, like cropping an image. For this kind of magnetic data, that would just distort the signal. So they came up with their own technique called block masking, where they literally hide entire blocks of sensors from that student network. It's a method that's perfectly tailored for this very specific type of noisy sensor data. So, with this brilliant self-teaching method, how much data did it take to build a foundational understanding of touch? Get this, just 4 hours. 4 hours of a robot hand basically just playing around, squeezing, sliding, and turning 14 different everyday objects. That's it. That's all it took to pre-train a model that fundamentally gets the physics of touch. Okay, so the theory sounds amazing, right?
It's elegant. But how did Sparsh-skin actually do when they put it to the test in the real world? Let's look at the results.
The researchers put it through its paces on 4 really challenging tasks. They were designed to test all different aspects of dexterity. Things like estimating force, figuring out what a joystick is doing just from touch, tracking an object's position as it starts to slip, and the big one, learning a complex task like inserting a plug into a socket.
And we're going to zoom in on that last one, the plug insertion task. Because as the researchers call it, this is a fundamentally tactile job. Vision alone just won't cut it. To get it right, the robot has to feel for the edges of the socket to line things up. You know, just like we do when we're fumbling around behind the TV.
And the results are, well, they're just incredible. Take a look. A robot using only vision succeeded just 20% of the time. Not great. If you add in the raw tactile data and try to learn from scratch, that gets a little better, up to 40%. But when you use the pre-trained Sparsh-skin model, the success rate jumps to an amazing 75%. I mean, that's not just a little better, that is a massive leap.
Let's just put one big number on that. This represents a 56% improvement in both performance and sample efficiency over the old way of doing things. That right there is the power of teaching a robot to understand touch first before you ask it to do a complex task.
So, what does this all mean for the future of robotics and dexterity? This isn't just a small step forward. This really feels like it could be a whole new way of thinking about how robots learn to interact with the world.
So, to recap the biggest contributions, we've got a powerful general model for magnetic skin, we have better learning algorithms designed specifically for touch, and super importantly, they've released a large open-source data set so other researchers can build on this work. Now, of course, the journey's not over. There are still big challenges, like getting better at understanding how touch changes over time and generalizing to objects that are moving around in 3D space.
But the researchers themselves frame this perfectly. They see Sparsh-skin as a major step towards foundation models for touch. Think about how large language models have completely transformed AI for text and images. Well, a foundation model for touch could do the same thing for robotics, a universal understanding of physical interaction that you could just plug into any robot for any task. And that kind of leaves us with this one last huge question to think about. If a robot can finally feel and interact with the world with the same kind of nuance and sensitivity as a human hand, what are some of those incredibly complex tasks that feel like pure science fiction today that might just become totally commonplace tomorrow?